Here we have a calculus problem in related rates. Okay, let's go the information. PV equals to C, where P is pressure, V is volume, and C is constant. The pressure is increasing at the rate of 20 kilopascal per minute. Find the rate of change of the volume, and the pressure is 150 kilopascal, and the volume is 600 cubic centimeter. Okay, here we have an equation which connects the pressure and volume. That is PV equals to C. And so we have the rate of change of pressure. That is, the pressure is increasing at the rate of 20 kilopascal per minute. So we have the rate of change of pressure with respect to time. So that because the pressure is increasing at the rate of 20 kilopascal per minute. So, and also they ask us using this information, they ask us to find the rate of change of volume when the pressure is 150 kilopascal and the volume is 600 cubic centimeter. Okay, so whenever we have a change in a quantity in calculus, we can express that as a derivative. So here, since the pressure is increasing with respect to time, so we can express this change as a derivative with respect to time. So, and also they ask us to find the rate of change of volume. Rate of change in volume means they ask us to find how the volume is getting changed. If we want to measure the change in a particular quantity, so I have to find the derivative of that quantity. So anyway, so I have to find the derivative of derivative on both sides of this equation with respect to time. So because the given rate of change is over here with respect to time, so now let's find derivative on both sides over here with respect to time. So here P is a variable and V is also a variable, that is P is pressure. So I know I'm saying that pressure is a variable because the pressure is increasing. Whenever a quantity is changing, it may be increase or it may be decrease. So it has to be considered as variable. So when the pressure is increasing or decreasing, definitely the volume also will change. So volume also has to be considered as a variable. And the question itself clearly says C is a constant, so it's a fixed value. Anyway, so when I find derivative on the left side over here, here we have a product of two variables. Whenever I want to find derivative of a product of two variables, I have to use the product rule. So that is, I have to keep the first variable P as it is, and now I have to get the derivative of the second variable B with respect to time, then I'm getting dV over dt. Now I have to take positive sign. Now I have to take the derivative of the first variable with respect to time, then I'm getting dP over dt. I have to keep the second variable B as it is. Okay, now if I get the derivative of the constant C, it will be 0. Whenever I find derivative of a constant, it is always 0. So because derivative means we measure the change in that quantity. Actually, it is a constant. In a constant, if I measure the change, so I won't be getting anything. So that's why I'm writing a 0 here. So change in the constant is 0. Okay, now in this equation, I have to find the value of dV or dt, so which gives a rate of change of volume with respect to time. So for that, I have to plug in the values for the remaining three quantities. Okay, they are asking us to find the rate of change of volume when the pressure is 150 kilopascal. So that is, I can plug in this 150 for this P. And also, they are asking us to find the rate of change of volume when the volume is 600 cubic centimeter. So this 600 we can plug in for this V over here. And for dP over dt, already we know that it's 20 because dP over dt expresses the rate of change of pressure. So with respect to time, it's given over here, it's 20. Okay, now let's plug in. So for this P, we can plug in this 150. So because the question is asked us to find rate of change of volume when the pressure is 150 kilopascal. Let me plug in 150 for this P. And for dV over dt, I have to find the value. So for dP over dt, I have to plug in this 20. That is change in the pressure with respect to time. I plug in 20 over here. And an important thing we have to notice over here, the pressure is increasing. Since it's increasing, so I'm taking this value 20 over here with positive sign. In case if the question says it's decreasing, I have to take the same value 20 with the negative sign over here. Okay, times the volume is of 600 cubic centimeter. We can write 600. We can plug in 600 for this volume equals to 0. Then I'm getting 150 times dV over dt positive. And I multiply this 20 and 600. I'm getting 12,000 equals to 0. Okay, to solve for dV over dt, first let me get rid of this 12,000. For that, I have to subtract 12,000 from both sides. So when I do so, this positive value, negative value will cancel. I'm getting 150 times dV over dt is equal to, I'm getting negative 12,000 on the right side. Let me write the same equation over here. 150 times dV over dt equals to negative 12,000 we have on the right side. So to solve for dV over dt, I have to get rid of this 150. For that, I divide both sides by 150. When I do so, this 150 will cancel out. So dV over dt is equal to, when I divide this 12,000 by 150, I'm getting 80. So I'm getting negative 80 as a value for dV over dt. So dV over dt is nothing but the derivative. Derivative means a change in a quantity. So that is change in volume with respect to time. So here we get dV over dt as negative sign. That means volume is decreasing. When the pressure is increasing, the rate of 20 kilopascal per minute, the volume is decreasing. So this negative sign indicates there is a decrease in volume. So how do you have to write unit for this value? So here in denominator we have V over here. What is the unit of volume? So clearly it's a cubic centimeter or centimeter cube. And in denominator we have T. T is time. So what is the unit of time? So clearly it's given minutes. So we have to write a minute in denominator. Therefore, the rate of change of volume is negative 80 cubic centimeter per minute. In other words, we can say that the volume is decreasing at a rate of 80 cubic centimeter per minute.